And now another topic we are going to discuss is about the semantic webs in artificial intelligence. Now, what do you understand by a semantic and what do you understand by the semantic nets in artificial intelligence? So semantic का मतलब क्या है? It's simply we are talking about semantic network in a knowledge representation only. So it's simply a knowledge representation technique for organizing and storing the knowledge. Now we are talking about organizing the knowledge. Semantic networks are a type of a graphical model here that shows the relationship between the concepts, ideas, and objects in such a way that it is for a human to understand. So what do you understand? Simply the semantic networks. So it's a kind of a network that refers the interconnected between the various data can be exchanges or it can share the resources between the various devices also. And what do you understand by the different or how we will basically model the things in a form of a graphical representation here. So what comes under the semantic network? It's a powerful tool in a field of artificial intelligence used to represent the knowledge and understand the relationship between the different concepts here. They are the graphical representations that can connect the nodes which represent the concepts with the edges which represent the relationship. So simply semantic where we are talking about the various concepts are connected with the how the various concepts in a particular artificial intelligence applications are connected. We are going to discuss in terms of a semantic network. So semantic networks are widely used in a natural language processing and the knowledge representation and the reasoning system. So how you define what is a semantic network? A semantic network is a form of a knowledge representation that visually illustrates how concepts are related to each other in a particular system, in a particular application. So in AI, it helps in structuring and organizing the data in a way that machine can interpret and process and use it for decision making. So again, here we are talking about the analysis of a data. We are talking about how the data will be get structured, how the data will be get organized, so that the machine can interpret, process, and use that data for the decision making. So nodes in the semantic networks are represented between concepts, and the edges define the relationship between these concepts, such as this concept is a part of this concept, or this concept is a part of that concept, is a relationship part of a relationship or related to relationship. For example, in a simple semantic network, we are talking about the concept of dog might be connected to an animal with and is a relationship indicating that the dog is a type of an animal, right? So simply we are saying that the dog is a type of an animal, or simply this is a type of a vehicle. If we are talking about a particular car here or a bike here, so we are simply saying that this car is a type of a vehicle, this truck is a type of a vehicle. Simply we are talking about is a relationship, part of relationship or related to relationships here between the concept here. Now, knowledge representation techniques in artificial. So, when we have talked about the artificial intelligence have several knowledge representation techniques that have been developed to enable the machine to process, reason, and understand the information. We have discussed this, right? So, what are the knowledge representation techniques? We have discussed this. Yesterday, we have discussed this that the logical representation can be there and the semantic network can be there and the protection rules can be there and the frame representations can be there. So here we are talking about in the logic representation, we have talked about the predicate logic. Now we are talking about the semantic networks, and then we will talk about the partition semantic networks and the parallel semantic networks. Then we will discuss the frame based data structures that represent the knowledge representation in the AI. So in that case, what are the different types of a semantic networks? First, we will discuss in the semantic networks. So semantic networks can be categorized into various types on the nature and the purpose, the relationship they represent. So What are the first is a definitional network. Simply here we represent the hierarchical relationships often used in the taxonomies or the ontologies. They define the concept by their relationship to more general or more specific concepts. And we have discussed about the ontologies yesterday. What do you understand by the ontologies? So we have discussed about the various knowledge representation techniques, and in ontologies we have talked about it's a structured representation of a knowledge of when we are talking about a particular domain here. So different often used in a different domain. We are talking about the hierarchical relationships here. So it defines definitional networks are used to represent the general or the specific concepts here. Right in here again we are talking the same example. The dog might be defined as a type of a mammal, which is internal type of a animal. Now the assertional networks. Now what do you understand by the assertional networks? It represents the specific facts or the assertions about the individual instances of concepts here. So they often describe the property or the attributes of a specific entity here. We are talking about the specific attributes or the specific individual assertions or the specific facts. So here we are talking about, again, we can take an example here like an assertion network might represent the fact that the Rex is a dog, the Rex has a brown fur. Again, specific. We are talking about a specific property here. Or simply, what do you understand by the assertion is we are now more specific about a dog that we have talked journal in a differentiational network here. Now, what do you understand by the implicational network? So, implicational networks focus on representing the logical implications between the concepts. Now, we have talked about the general definition. We have talked about the specific definition also. Now, we are talking about the logical implications between the concepts. They are used to infer new knowledge from the existing relationships. Now, what are the existing relationships? Are there? Simply, we are talking about the machine will learn. The machine will learn from the existing relationships or the solution that are present in a system. So they are used to infer new knowledge from the existing relationships. Like if all dogs are mammals and Rex is a dog, an implication network can infer that the Rex is a mammal. We are again a new statement has been generated based on the old statements or the relationships that all dogs are mammals and Rex is a dog. So we can say that Rex is a mammal here. Another semantic networks, right? We are generating a meaning. So what are the executable networks? Executable networks are designed to represent procedural knowledge. Now, when we need to represent the procedural knowledge, what do you understand by the procedural knowledge? Where the relationships includes actions or the sequence that can be executed by a AI system, or simply we are talking about the procedural will be followed. The procedure will be executed by a system. And that procedure will be consist of a number of actions or a sequence, or simply we can say that it would be a collection of a number of instructions that need to be done after a particular task or after a particular event that will be triggered. So executable networks are there, which shows the relationships where the relationships includes action or sequences that can be executed by an AI system in a serial manner or whatever. So an executable network might represent the steps in a recipe one by one, such as add a water to a pot, followed by a boiling water, right? So when we are talking about a particular procedure that includes a step-by-step representation, we are talking about simply the executable networks. Now the learning network. Now the semantic network can be a learning network. How? Learning networks are dynamic. We have seen the challenge about the learning network or the learning or the dynamic in a first order logic. So here in a semantic, we are talking about the learning networks that are dynamic and evolve as the AI system learns from a new information or when the data is getting changes or that can be idle for the real world problems or the real world changing data. So they update the relationships and the node based on the new data or the experiences here. Like in a learning network, an AI might update its understanding of a dog as it encounters a new breeds or the characteristics, right? When we talk about the new statements, or simply you can say that when the new statement about a dog animal will be feeded in a system, then it will interpret the other new statements, which is our learning network. It will learn from a new data and it will update its knowledge base. Another semantic network, we are talking about the hybrid network. Obviously, the combination of one or two or more types here. So, hybrid network combine the elements from two or more of the above types, allowing for more complex and the versatile representation of our knowledge. Or hybrid network might integrate definitional and the assertional aspects or specific aspects representing both the concepts about a dog and specific instances like a Rex also. So here we had talked about the dog, we had talked about the concept of a dog, and we had talked about the different types of a semantic networks that can be shown the relationship between the concepts which we had talked about. Now, what are the components in a semantic network? Now, how the graphical representation will be done. What are the components? So semantic networks are made up of several key components here. First is the lexical component. Now what is the lexical component here? It represents the nodes and the labels here. Labels, as you say, label is basically a definition of a particular node, right? Or the name of a particular node. So what the node represent? The fundamental unit of a semantic network or any graph when we talk about is a node here, representing the concepts which may be represented by a node or the entities or the objects within a domain of a knowledge. When we are talking about a particular domain of a knowledge, like take an example of a medical knowledge here. So we need to represent the concepts, entities, and objects and which will be represented as a node in a graphical representation here. So here, like we are including the example dog, animal, or tree is a node here. Now the label will be there. Again, the descriptive names or the identifiers associated with the nodes, providing a way to refer to the concepts they represent here. So again, how the what the name we are giving to our node or the identifiers which provide how the concepts are be representing here. Now the what are the structural components? Now structural components again is the edges or the links between the concepts and the types of a relationship we are talking about. Now what is the edges here? The connections between the nodes representing is a part of or it causes this or it is associated with this or the type of a relationship. This includes the hierarchical relationships like generalization or the inheritance, right? Generalization here is a relationship association, associative relationship related to, and a functional relationship. It causes or result in, it's a type of a relationship we are talking about. Now the semantic components. What is the meaning of a node? How the relationship will be interpreted or the knowledge will be interpreted here. So meaning of a node, the specific meaning or the interpretation of a node within the context of a network. We need to define a meaning. Then the interpretation of a relationships, the understanding of what the edges or the links between the nodes signify in a real world terms, ensuring relationships are meaningful and accurately reflect a particular domain here. When we are talking about a particular domain specific AI application here, so it need to ensure that the relationships are meaningful or unnecessary relationships are not present in a different nodes, and the nodes are also representing its meaning and are accurately defining that particular domain here. Now, procedural part, another component in a semantic network. We are talking about the procedural part. Now, we need to define the procedure also, or the rules also, or various queries mechanism, or the update mechanisms about the data, about the new information also. So first we are talking about the inference rule. Okay, sorry. We were talking about the inference rules or the procedural part of a semantic network. So simply we are talking about the inference rules here, or the rules that allow the network to drive a new knowledge from the existing networks or the relationships, as we have talked about this in the procedure also, like, or the new knowledge will be there. The dog is a mammal or a mammal is an animal. The network can infer that the dog is an animal, or the particular reasoning will be there. Now the query mechanism we are talking about. In a query mechanism, we are talking about the procedures for retrieving information from the network based on specific queries or the particular criteria. When we are talking about for this criteria, this particular statements we will need to execute it, or this procedure need to be followed for retrieving the information from the network, then we are talking about the query mechanism. Then the update mechanism. Update mechanism. Here we are talking about rules and the process for adding. Again, we are talking about the different procedure that need to be done for the process of adding, modifying, or removing a nodes and the links as a new information is introduced or a new data has been generated. So here we have talked about the different components, right? We have first we talked about the semantic network and the different types of a semantic network. Then we have talked about the different components of a semantic network. Now, what is the working of a semantic network? The working of a semantic network involves several processes that allow AI system to represent, infer, and reason about a knowledge. First is the knowledge representation, right? First, we need to represent a knowledge. The first step in working with a semantic network is to define the concepts and the relationship between them. First, the knowledge will be represented in terms of a meaning, in terms of a concepts, in terms of a relationship between them. This involves creating a network that accurately reflects the particular domain knowledge. Then the inference and the reasoning will be performed. Now the AI system can traverse the network to make the inferences based on the existing relationships that are present on the node. This process involves following the edges between the nodes to drive the new relationships or the new information or the new answer queries here. Then the query the network. Now what has been generated? Now the network can be queried to retrieve a specific information. Now the network has been generated, and further with the reasoning new information has been generated. Now how to use that network to query or retrieve a specific information? Now query can be made to find the relationship between the concepts and identify the categories between them, or extract a particular data points also. Now, updating the network. Now, what do you understand by updating the network? When the new knowledge will be there, or when the new data will be there, as a new information becomes available, what can be updated by adding, modifying, or deleting the nodes and the edges as the new information has been generated after the inferences and the reasoning. After the querying the network, the new data will be generated. So the network need to be updated by adding the different concepts and the relationship between them, by adding or modifying and deleting the nodes and the edges. This keep the network accurate and reflective of most current knowledge. Now the reasoning mechanism. Now, what comes under the reasoning mechanism or the semantic networks often use reasoning mechanisms such as forward chaining. We will discuss this also in our unit. Starting from our common facts and applying the inference rule to drive new facts. We will discuss all these examples. First, in our tomorrow lecture, we will discuss the semantic graph example also. We will discuss the working also with the help of a graph. And the first order logic we also discussed. So semantic network often use the reasoning mechanisms such as the forward chaining, starting from the known facts and applying the inferences rules to drive new facts. And backward chaining also will be there, starting with a goal and working the backward to see if the known fact can support it, right? For a particular working or a particular domain specific knowledge here. Now, what are the examples here of a semantic network in AI? What are the what different examples are there? The semantic networks are a powerful tool for representing the relationships and classification across various domains. Now, few examples we are talking about. Semantic networks can be applied in a different fields, or simply here we are talking about the applications to organize and understand the complex information here. Now, first we are talking about the technology stack classification. Now, how we are talking about the technology stack classification? We are talking about the different concepts and the technology here, the front end, back end, HTML, CSS, JavaScript, Python, Django, API here. And the links is a or this use this relation type of a relationships, and the label somewhere we are talking about a framework, the complete framework, somewhere we are talking about a Python language. We can say that somewhere we are talking about few technologies or the nodes are representing the concept of a web development. So in this semantic network, different concepts of a technology stacks are represented. HTML, CSS, and JavaScripts are linked to front end. Within and is a relationship with within a relationship, so is a front end techniques here. While Python and Django are linked to the backend, and it the uses relationship connects the various application programming interfaces to both the front end and the back end, indicating the role in the web development here. Or somewhere we are talking about the languages and the framework and the web development also when we are talking about a concept here. So here we can see the semantic web. Then in the food hierarchy, we are talking about the semantic network. Simply, we are defining again the nodes with the name of a fruit here. The fruit is a apple, or it can be a fruit, or an apple, or a banana, or an animal, or a lion here, right? In terms of a food hierarchy. Then we are talking about the links eaten by. Then we are talking about the herbivores, whether they are the herbivores or the carnivores or the predators. Like simply in this semantic network model, we are talking about the food hierarchy where the apple and banana are connected to a fruit, lion is connected to an animal, within a is a relationship, and they eat the eaten by connects fruits to the herbivores, animals to the carnivores, illustrating the dietary relationship in the food chain. Or simply we are representing here a food chain in terms of a semantic network. Now, how the programming concepts here? Another example, we are talking about the programming concepts. In the programming concepts, we are talking about different programming languages, the Python, Java, data types comes under its, integer comes under its, and simply we are talking about the concepts which are represented by the nodes, or the entities are represented by the nodes here. Concepts are the data type and the integers, Java, Python, and the programming language we are talking about here, the entities also. Links or the edges or the relationship between the concepts is kind of a or has a relationship. Levels, we will talk about here the programming language like the Python we are talking about, or the Java. These are the high level languages. When we are talking about the data type, numeric type is the integer type of a data type, right? And now what kind of a semantic network will represent in a system. This example demonstrate a semantic network in a domain of a program. So here the domain specific knowledge we can provide as a programming, which is Python and Java are linked to programming language within with an is a relation indicating they are a types of a programming language, right? So here simply we are talking about Python and a Java. Then we are talked about data types, which are the nodes are linked to the integers. We will link data types which are linked to the integers with a has a relationship, or data type has a integer type of a data type, or a float type of a data type, or a character type of a data type, and both are connected to a numeric type also, because data type can be a numeric type or an integer is a numeric type of a data type, showing the classification of a data types in a programming here. So again, this knowledge uh, which is specific to a domain of a programming will be represented by forming the semantic network in a AI system here. And this food hierarchy of a knowledge or particular domain, here we are talking about the food here, and then we have seen another example here which is related to a web development domain here, indicating the role of a web development. Now, what are the frames we have talked about, and we will talk about frames in a detail. So what are the semantic networks and what are the frames also? Before that, we will talk about, because when we will talk about the frames, we will talk about the difference between a frames and the semantic networks. First, we will talk about various, again, what are the various applications of a semantic networks in AI. Now, as the common applications we discussed in the AI, first is the natural language processing is an application. All the various applications here we are talking about. So first is your natural language or the NLP here. So in NLP, semantic networks helps in understanding the meaning of our words and the sentences by representing a relationship between the different words and the concepts. So, right? Then we need to understand the particular domain or expert system. In expert system, semantic networks are used to represent the knowledge of a human expert, enabling the system to make a decision or provide the recommendations based on that knowledge, or simply here we are talking about the inferences. Then the ontology development, because here we are talking about a particular domain specific knowledge representation or the meaning of our concepts and the relationships here. So ontology development or the ontologies which define the structure of a knowledge in a particular domain use the semantic networks to represent the relationship between the concepts within that domain. Then the information retrieval. Now it works on the new information also, and from the existing information, the new information can be retrieved. So semantic networks enhance the information retrieval by allowing the system to understand the context and the relationship between the different pieces of our information. Now it can understand the different concepts between the what are the relationship between the different concepts, which can lead to the accurate search result because it understands the meaning what has been stored. Again, when we talk about it understand the meaning, so simply we are talking about the machine learning, right? So machine learning or the with the help of the semantic network, we are implementing a machine learning technique in some machine learning applications. Semantic networks are used to represent the interpretability of models by providing a structured representation of a knowledge model that has learned here. So different semantic um, knowledge models can be used so that the machine can learn. Or the simply we are talking about with the help of a various inferences and the rules, the new information will be generated from the existing data, and when the new data will be generated, the data will be get updated. In terms of that, the new meaning can be generated. So advanced, now we have talked about the application. So what are the advantages here? Intuitive representation, flexibility, support for the reasoning. So again, when we are talking about the intuitive representation, what do you understand by the intuitive representation? Semantic networks provide a clear and the intuitive way to represent the knowledge, making it easier for both humans and machine to understand the complex relationship because it basically shows the concepts, not simply a terms of a variable. It simply defines the variables or it defines the nodes and with the help of a labels also it define or it basically explain the nodes here. Now, what do you understand by the flexibility? It can represent the various type of relationships and are flexible enough to be applied across different domains and the application. It can be used in a different domains and the application. And now the support for reasoning. As we have discussed, semantic networks facilitate reasoning by enabling AI system to infer a new knowledge based on the existing relationships also. Right? So tomorrow we will discuss about the frames and we will discuss about the another semantic networks or the parallel implementation of a semantic network and the partitional implementation of a semantic network. Or simply we will talk about the distribution in the partition and in the parallel simply we are talking about the processing in terms of a parallel. Everything will be executed or the processed in a same time.